creating a part, before that we have to set the work directory. By setting work directory, we have click on the file, then click on the set the work directory. Now you may choose your desired folder, as I am choosing the D folder in the ABAQUS. Okay. Now creating the part with the name CT and use deformable and make the solid and click on continue. Starting from the coordinate 0, 0 and the against coordinates of the rectangle is 63.5 and 60.96. Now we have get the circle square. Now creating the bottom line for the offset, click the offset of the bottom line, which is a 28.8925. Now by clicking the new offset line and make the again offset command 1.5875 and 3.175 after that. Now clicking on the vertical line for the offset, which is 12.7, and after that we have choosing the above line for the offset, which is 16.5. Now creating for the bottom line. Basically these lines are for the circles. Now we draw the circle, which is the 6.35 mm on the both sides, top and bottom. Trimming the excess lines, which is not useful, but we are leaving these one because we have created the notch for our geometry purpose. Offset for the vertical line, which is 19.05, and after that we have select the second line for the offset, which is 22.86. Using the SP line for creating the notch, we select the trim for the removing the absence of making our geometry purpose. Completely the sketch by dimensioning or providing the dimensions to the complete whole drawing sketch. We set the extrude, which is 25.4, click OK. Now we get the part. Now we have created the rigid body, which is a pin, name as a pin again, and make it the analytical rigid. Continue. 0, 0 and then 6.35, 1 point, 25.4. So making the construction line, clicking the construction line on the left side, making done, and we get the 360 revolved piece. Now we are making the reference point, making on the center of the piece. Now we are assigning the material. By assigning the material, we have named the material for solder, SOLDER, choosing the elastic property, which has a Young modulus and the Poisson's ratio.
By mentioning the young population properties and the Poisson's ratio for the plastic model. And now we have select the plastic model, which has the yield stress values and the plastic stress.
These are the values you can see for the plastic property.
As seen, we have values, completed property of plastic model, then click OK. Now we have to create the section. I name the solder solid and homogeneous continue. Select the CT part before that and then OK. By selecting the region of the CT part and then clicking the OK. Now we have to make the assembly for the part. Let's select the both parts at the same time, or you have separately selected the pins and the CT part. I have selected here the 2 times the pin, and by seeing this, now we have to translate the rotation of the parts, pin parts. So by selecting the first regions of the part, mentioning that the part is over there by rearranging, we see. Now selecting the second one by checking the RP position, and now move the beside the CT part. Now we can see here are the both parts are arranged. Now we have to face aligned with the part by first of all select the part, pin part, and then the CT part. Now we see the both parts is aligned with the CT. So by translating these pins in the part compared test model part, by selecting the top pin notch of the pin and clicking on the center of the pinhole. Apply for the second one, SM. We see the both pins are arranged in their region. Now we have to create the steps by clicking the create steps. Step 1, initial, and then general and the static. So we see here the total time period we have selected 1.2 seconds. The incrementation is start from the 0.05 with the 1 e power minus 9 4 minus 4 into the 1.2, and so we have to. And now we fill the outputs that we have to select the desired output what we want, as stresses, strain, and the displacement of the part. And the reaction forces as well. We have to select that one. Clicking OK. After create section, we have the interaction, but before that we have the assembly. In the assembly, to make sure the translate the pins for the time being to make the interaction of the both parts. Now we have to select the both pins instance and move backward to the with the z axis rotation. So minus z axis we have put here. So we see the pins are ejected from the part. Now we have to make the interaction with the CT part. So click on the interaction and then create constraints with the type. Now we have to select the major surface, which is the master surface, which is the pin's outer surface, and after that we have to select the slave surface, which is the pin's inside pinhole inside surface. So by clicking that, we see the all requirements like it sure, and then for this apply for the second pin at the same procedure, clicking the outer surface of the pin and then the pinhole inner surface as a slab surface. Now we have done with the both interaction of the pins. Now we have to rearrange the pins in the by making the assembly, translate or transfer the pins, create instance pin 1 and pin 2. Now clicking the main notch point and then the center of the pinhole. We see the pins are arranged on their specific position. Now we have to provide the load. By clicking on the load, we have to name it the fixed work. By we seeing that the load is in the displacement, so we clicking displacement, okay, and then select the pin 1. The pin 1 done, and we have to make sure the load we have applied in the y direction or u2 direction, so we have leave it. Therefore we make the u1 and u2 u3 is 0, and we have to create the fix 2 for the second pin at the same displacement setting. Now we're selecting the pin 2, and here the u1 u2 and u3 three direction all are equal to 0 because there is no movement, there is a fixed point. By selecting that, we have to another create the condition boundary condition, which is a displacement. So we select the pin first, which has to displacement in the direction of u2. Now we have to make the size 0.1. Now we have to apply the mesh on the part, but before that we have to select the CT part. Then now we have select the global seed size, which is a 2. We have, and we see the mesh. We have to select the advancing front face. Now we have to assign the element type, that is explicit 3D shell, and then we have to perform mesh. Yes, click OK. Now we see the part is whole meshed up, and we see the desired mesh is required. Now we have to create the job for that one. Before that we have to create on the grid. Now we can name the job, create job with the compact test in here by clicking continue. So we see all the things are as through they are by clicking OK to make forward. Now we see we have to perform the data check. By data checking, it takes time mostly, and now we submit the data. After some time, it will be running in the phase to make the iterations, and then completed in the monitor. Now we see in the monitor phase, we have the increment in the 8 steps. It is all the attempts with the 1, and there is all the other things. There is time of frequency, and we see. Clicking dismiss. Now we are transferring in the visualizer, or click on the result and visualizer. We see here is all the field outputs. We have the displacement, strain, stress. We see we have changing on the displacement phase by U, and we see here the movement in the part. It is applied in the displacement phase, in which in the visualization now we have to apply the animation on that. So we changing the speed by from clicking on that. So we see as the part is when the displacement is occurred with respect to time point 1.2 for 1.2 in the u2 direction or y direction. We see in the connecting side, we see there is a red application. It means the highly stress over there. You can change here the output field as you want. as you desire. So the displacement is shown here. When we see the animation of the display, we see the upper part is most highly displacement occur the upper part. Now we see the compact force and SE yield on that, and we see there is a compact modulation. Say here the strain property on the part we see. So there are all the output fields are that we have selected over there. We can see over here. Also we get the reactive force, and now all the field output we get here. This is a stress. You can also select the with respect to frame, where the frame, in which frame the what is the behavior of the part. So we select the fifth frame. We see in the fifth frame and by continuous in the legend dialog, we see here on the time 4.6, and in the legend we also see the 4.176, which is occurs at that direction on the part angle. So this is all the time. Now we have to generate the XY data graph. By clicking on the XY plotting, then select the output, data field output, and selected what you want to show in the graph. Now I have selected the strain and stress, and checking the element node. Edit selection of the element node from the visualization by click on the edit selection and then plot. On that node we have to get the strain and stress graph with respect over the time. We get the strain and stress over the time on the mentioned or selected node. We can change the node by selecting that. We see there is a graph which is also making the same output, but we have also changed. We see the change, so we selecting this one, and now we have to plot. We see there is a little bit difference on the upper part, strain and stress with respect to time. Now we have to select or draw the strain and stress graph with combined. So click on the operate XY data, output XY data. Now we have the combine function. We have used combine XX, and by double clicking the desired output, we see there is a strain versus stress graph we have getting there over there. This is a strain domain axis, or we have the stress. Through this we have to get the two separate functions. Now we have to export the all data graph in the Excel format. By plugin, select the Excel, and now we have getting this window. And by selecting the particular data that you want in the Excel, apply. So you see there is a data we have occurred on axis in the Excel, and we see also the graph is generated in the Excel. So these are both columns with the data. The A column represent stress, and the A column represent strain, and the B column represent stress. You can also edit the data over here if you want, but there is a data that is taken from the ABAQUS. So this is the Excel data. Now we have also generate the graph or plot the graph in the for the displacement and the reaction force by selecting the output ODB field output. So you have to select that you want the displacement is selected with magnitude U1, U2 and U3 in the both three directions, and then we have select the reaction force. by selecting node. We have to select the node and then click plot. And now we see that with respect to time, we getting the displacement, force, and strain, because strain I can't check and check from the previous one. So that's why we have get. This is all about. Thank you for watching that video.